Happy Sunday. This is PFG Live, and you are going to get flatter. Welcome aboard. We've got a bunch of cool people showing up here. I can't even keep track of them all. First weather report in on the Discord server is Unix Carbide in Brooklyn, New York. Reports 67 degrees Fahrenheit and raining, so 100% humidity? I think so. Evils says a whole bunch of things, which include, but is not limited to, it's nice out. Tucker says it's 66 degrees Fahrenheit and partially cloudy. It's partly cloudy, sir, in the Buffalo of the New York. Dale says it's 22 degrees science and smoke in the northwest of America's top hat. Yes, so we have a bunch of wildfires happening in Canada. Let's not forget those folks. Derv Nutron is saying it's 63 degrees Fahrenheit, 84% humidity, mostly cloudy in Hartford, Connecticut. Welcome aboard, sir. Self-tapping, and believe me, he is, 70 degrees. Okay, do not. 70 degrees Fahrenheit and sunny in Strasburg, Ohio. Josh says, due north in Montreal, Quebec. At Charlie Yankee Uniform Lima, where the winds are 240 at 18, gusting 23, 15-mile visibility, light showers and rain, few clouds at 2,500 TCU. Oh, I can't remember. Broken at 4,000, broken at 7,000, and a bunch of other stuff. Arstead says it's 66 degrees Fahrenheit and beautiful in Peoria, Illinois. YouTubers, we're going to get to you next. Quentin, welcome aboard, sir, says it Echo Hotel Kilo Delta. It is. Where are you? Winds are 120 at 11 knots. 090 variable 150. Weather is insignificant. Saunders Works, welcome aboard, sir, says it's 69 and sunny in Zanesville, Ohio. Welcome. And Evils is drinking Fruji. Let's see. The YouTubers, we have a bunch of guys showing up. The first guy in on YouTube was Geek Gaming News, John, in a place called Windham, New Hampshire. He says it's currently 59 degrees and the winds from the north at 1 mile an hour. Welcome aboard, friend. CJ Stevens says it's 71 degrees and very sunny in East Tennessee. Welcome aboard. Carl Tauber in the People's Republic of Rhode Island, 62 degrees, gray and miserable. That's uplifting. Another company called Saunders Works says hello from Zanesville, Ohio. He's got both hands going here. It's still 69 and sunny. Art that makes art, Wes, he says it's cool. We think so too. Edward says it's sunny in Sunnyvale, California. What are the chances? Harvey Newman, welcome, sir. He says it's 63 degrees and partially cloudy in Santa Rosa, California. Warren Jones, my neighbor to the north in Sutton, New Hampshire, 66 degrees Fahrenheit and mostly cloudy. Did we get Warren? I think we got Warren. Ted Hyde, Casa Frog Pro Resources down in Eustis, Florida, says it is winds are variable at 3 knots, visibility 10 miles, few clouds at 8,000, few clouds at 9,500, temperature 32, dew point 22, altimeter 2998. Remarks, does Air Spencer fly Boeing equipment? Check them doors. We have duct tape, dude. We don't, no problem. We duct tape all the doors. Hi, guys. Did I miss anyone? I got Harvey there. Everybody's checked in. Excellent. There'll be finger sandwiches in the after-party roundtable, some of your favorites. Don't worry about it. So it's been a weird 2 weeks. We missed last week because of the holiday, the Labor Day weekend, in which we had 3 days off. And I hope you enjoyed it. And I did some labor. Actually, I was going to show you a picture. I think it was during the time that we would have otherwise been on the live. I was fixing a mailbox bracket. Now I shared this on Instagram, but I did not share it here. So this was last weekend. Mailbox bracket broke. Note the passive tense. And we set it up for welding. It turns out, I didn't expect this going in. It turns out that this was a cast aluminum bracket. I guess I shouldn't have been too surprised. And I was ready for it to not work. So we ground it up. It's maybe both evils, past tense and passive voice. Maybe it could be a pastiche of both. So here's the pictures of the welding. It went super well. This is Jared. Jared's helping me on the bench. He did a video here somewhere. The first tacks came out great. I hope my welding instructors are not watching. So we started seeing some schmutz in there, and I'm like, yeah, this is how it's going to go. It's going to be horrible. And then everything cleaned up. It's like, look at that. It came out great. Oh, here's a short video for your pleasure. I didn't know we could do this, but we can. And if you were not on the pre-show, and you want to guess the frequency, go right ahead. and there's Jared. Okay, good. I thought you'd enjoy that. So that was the beginning of this past week, and otherwise we've been working on a bunch of fun stuff. We finished up the last of the B200 balancing rings and cleaned up from it. That was great. I think I posted pictures on Instagram. There's I think that was the last one. That was the last balancing ring. And they came out beautifully, and they're marked B200 2025. And there was the last cookie. Cleaning up from the last balancing ring to rule them all. I then did a thorough cleanup. Here's a picture of the bag filter had these fines, and it did a really nice job of picking them up, and we got those cleaned up. And that was kind of the beginning of the week. And then we got onto some stuff that we're going to talk about today in some detail. So I'm just looking to see what else you might have missed this week. I guess that's about it for now. So today we have a couple of interesting topics. And if you guys have questions, suggestions, or comments, don't hesitate to put them in the chat. We have folks in Discord. Welcome aboard. DBX, Quentin, Dale, Carl Tauber, Derv, Saunders Machine Works, Evils, Warren Jones, Unix Carbide, Tucker, Josh, Ted Hyde, Self-Tapping, and Arsted. Welcome aboard, all you guys, and everybody on YouTube. So, let's see. I have been fighting Fusion. I'm not going to lie. One of the projects that we're going to be talking about at some length today, and in fact is pictured on your screen, you saw the thumbnail, is this lap right here. And this is a very exciting lap. So I'm going to get into what that is, but I was able to get an SVG file that had a pattern which I wanted to engrave on a lap. Now, before I had talked to my customer, yeah, okay, we'll so Ted Hyde asks a question about the patterns, which I think I'm going to handle a little later. And Saunders Machine Works says it looks puzzling. It is. It's even more puzzling if you don't have all the pieces. So I had this pattern, and it was an SVG file. SVG stands for, and I will be corrected if I'm wrong, Scalable Vector Graphics. So basically, it's a vector graphics file. And I wanted to get that into Fusion, and then I wanted to say to Fusion, hey, Mr. Fusion, I want you to engrave this pattern, these vectors on a plate. Now, how many of you think that should be easy? Raise your hand. Oh, I see you, Mr. CSK. Welcome aboard. So by the way, Mr. CSK, you're getting the background. This is how it all started. Actually, that's not true. This is how it ended this week, and then we'll get into why I went this way. So if Mr. CSK, if you have audio available and if you have video available, we'll try to bring you in later. You're doing it exactly right, but you're a surprise for later. So I go into Fusion and do all the things you usually do, and I tried to engrave the pattern, and I got some decent success, except Fusion would decide to leave out some line segments because it felt like it. This was not good. So I tried A, I tried B, I tried C, and then finally I asked the universe, and I cloaked my request in I'm trying to engrave a map of the U.S. And the reason I said that is because I had not talked to my customer for whom I'm doing this work. And now that they're in the loop, I can start talking about it. But it was the same problem. I actually did that. I actually downloaded a map of the United States. And guess what? SVG file. Everything's great. I go to Fusion. I say, I want to make a tool path which is going to engrave this. And same thing happened. It was not smooth, not a good experience. So on the Discord server, an excellent place to get help from your comrades, I posted my problem. And I also asked some people directly on chat, other channels, and I tried everything that everybody suggested. I went to my good friend Chat. Do you know Chat? He works at the next screen. His last name is GPT, and Chat GPT said, "Oh, you should use this feature in Fusion called Sketch Doctor." Now, it may come as no surprise to you that there is no feature in Fusion called Sketch Doctor. So I go back to my friend Chat and I say, dude, what are you talking about? And Chat says, oh, you're absolutely right. It doesn't exist in that anymore. So I'm like, all right, yeah, you go back in the corner. So finally, light dawns on Marblehead. One of the things that I almost dismissed, Geek Gaming News, which is John, says, gosh, I'm waiting for Clippy to show up. This was a Clippy moment. I see you're trying to do something useful. Here's some information, which is useless. So, one of the things that John Saunders said to me, John's here, that's Saunders Machine Works. He said, you can make extrusions, and then you could ignore that sketch file that you imported, and then it will work on the extrusions. And I'm like, yeah, that's crazy talk. Well, guess what? I go back to my my Fusion file, and I had to select. It actually wasn't trivial because I went around and I selected non-adjacent tiles. Now we're going to call them tiles, each one of which was a vector loop. And I extruded them 1/10,000th of an inch. And then all the other ones that I didn't choose on that first extrusion, I chose again, and I extruded them 1/10,000th of an inch. I think it took me 4 tries to get them all selected and extruded. Because if you selected adjacent ones, it would extrude the whole thing, which is not what I wanted, because then you'd lose the border. So that was the hack. The hack was going around to each one of these vector loops, okay? In my case, tiles, spoilers, and extrude them all 1/10,000th of an inch. And in our world, we call that, in the world of CNC milling, that's called noise. So we ignored the fact that I just made my surface higher by a 10,000. It didn't matter. So it worked. Then I was able to go in and say, I want you to do, it had to be the trace toolpath. And then it went around and did everything I wanted. So in Fusion, if you can't do what you want to do, I left the world of selecting lines in the sketch, and I entered the world of selecting surfaces that were extruded, and they're two different worlds. So I couldn't do it in world number 1, even though I thought I should. And then in world number 2, I was able to do it. Exactly. So I got it done. So there's a tip for you in Fusion, and that is if you're having trouble doing something in a sketch, make a hack solid and do what you have to do with the hack solid. And that's what I did, and it worked. And it was hard, but we got it done. So a big thank you to John. John has beat his head against Fusion enough over the last couple of years that he had the correct answer. Thank you, John. Your outstanding advice will be rewarded. So let's see. Oh, you don't want a lathe prize? So Saunders Machine Works, as you guys know, is one of the major proponents of the use of lathes in today's modern shop. This is well known throughout the industry. And I have to say thank you. Oh, you're going to want to watch this when you come back there, John. John's got a busy day. We actually talked yesterday. So I know that I'm not going to be incarcerated for the following. So, I don't remember where the I Love Lathe movement started, but the I Love Lathe movement started with John, and it has expanded literally around the globe. And you can't go anywhere to any kind of conference, Fab Tech, East Tech, any of the techs, and not have somebody come up to you and say, I love lathe. Do you love lathe? So the following is a tribute to the I Love Lathe movement, and in particular to our friend that we're proud to call a friend and a colleague, Mr. John Saunders. So please enjoy.
I love lathe.
I don't love all lathes, but I love this one.
I love lathe.
I love lathe.
I love lathe. Look at that finish.
I love lathe.
Lathe.
I love
Lathe.
Doink, doink. John, thank you. You mean a lot to us. I just want to say thank you, sir. Thank you on all channels. Oh, man. Tucker says 10 out of 10. Dale says, that's not tears in your eyes. It's lathe coolant. Oh, man. Edward says, lathes help make the world go round. That was more fun. If you knew how much engineering went into making that video. Anyway, if you enjoyed that video and you want to see it again, it is, hang on, I got to make it public. You can go to pfg.gg/lathe and you will see it. And also it is now available on the Kinetic Precision YouTube channel, which you can access via all the usual means. Thank you, John. I love lathe. Also, a big thank you to, so John says, the irony, I'm literally preparing our ST20Y, our last lathe, for sale. We will then be lathe free. It's part of our 12-step program. That is awesome. So we also have these magnificent 3D printed Saunders Lathe Works items, which we will put the STL for this up on the links page. It'll take a day, but just for me to get my act together. But yes, Saunders Lathe Works. By the way, the stickers, and you can see the stickers. I can't stop laughing. The stickers are available, okay? And that will be in our sticker pack. And, just get a hold of me and we'll get you a sticker. And John, you got some goodies coming, so. Evil says, surely that last lathe is getting an original printed badge. I think we need that sticker on that last lathe. I think that's a good idea. Derv says a 12-step program to be free of 12-station turrets. There you go. And good morning to Machine New Zealand. Welcome aboard, sir. So, yeah, that was a couple hours of work, but worth it. So the video's out there. Enjoy. Have a good time. Now, so Mr. CSK, you see why we're so serious here? So let's get down to business. Let's talk about these laps. So first, a little history. When I first got, okay, we'll get you more. Shoot me a DM. We'll get you some stickers. When I first got interested in lapping, I don't remember how it happened, but I did the thing that everybody does when you get interested in lapping. You go to eBay and you buy laps because that's what you do. They're kind of expensive, right? So I go to eBay and I purchased, I think I purchased 4 laps that looked like this, okay? It's a square lap. It's got quadrile grooves in it that are pretty deep, actually, like 50 thousandths deep, and they're rectangular. And this was a commercially available lap, although I have not been able to decode the trademark, which is stamped on it. So I don't know exactly where it came from, but this was pretty solid. And I literally messed around with them for a while. And, did I know what I was doing? Absolutely not. So I had 2 of those and then 2 with a finer pitch. And they were both quadrile. They also both had the grooves going to the edge of the laps. That's important for more of the story. So then I said, I have to start making my own laps because there was a couple of problems with a square lap. One is its squarosity is going to, you guys aren't going to believe this, we just lost power. But I think we're good. When you see the lights come on, you'll know I got power back. The squarosity of the lap means Either I'm on generator or the lights just came back. Oh, Evils, don't worry. We have UPSs on every computer, every router, everything. Plus we have a generator. This is, after all, New Hampshire. So a square lap, let me back up. When you use a lap, you have to condition it. And that means your part rubbing on the lap with your herbs and spices, which might be a diamond slurry. It might be some other type of abrasive material. And when you rub your part on it, the object is to get your part as flat as the lap. Cool. So what the buy a thing off eBay does not teach you is that what you need to do is keep your lap flat. And there's all sorts of wives' tales about how to do that. But eventually, you learn that if you have two identical laps and you rub them together, you can maintain the flatness, put an asterisk on that. You could maintain the flatness by conditioning them together. And so I decided I'm going to make my own laps, and I'm going to really figure this thing out. My laps are going to be round. Hi, Robin. Welcome aboard. So if you go back in my videos, you'll see the beginnings of the 6-inch laps. And here is the 6-inch lap. Okay, so if you're listening to the audio podcast, this is a round 6-inch lap that also has a quadrile groove pattern, but it has what I call the Renzetti trough. So Robin's in the chat now. So the grooves do not go to the edge, and that saves some of your slurry from dripping off the side. And that's a very nice feature, and I can tell you from a practical standpoint, it works really well. So that this one is a 6-inch round lap with quadrile grooves, and they're about 30 thousandths deep. It was cut with a V cutter, and I can tell you that they work quite nicely. I could also tell you that you make them in pairs, okay? So that you have a conditioning lap and a working lap. Now, this isn't going to be a lesson on lapping. Some of my other videos talk about those details, but I can tell you that the work only ever gets rubbed on the working lap, and the conditioning lap is only used for flattening. So my 6-inch laps were very successful, and generally I've been using 3-micron diamond slurry. So here's what it looks like when you go to McMaster Carr or some other favorite supplier and you buy a bottle of 3-inch diamond slurry. It is basically a liquid with diamonds in suspension. And those diamonds happen to be, on average, 3 microns in diameter. Now, one of the tidbits that I picked up from Robin was, because he also was doing a deep dive into this stuff. He said that liquid that they are suspended in is non-trivial. And don't diss the liquid. So don't go buy powdered, diamond and then try to mix up your own, because that they put a lot of engineering into that. That was a very good tidbit. So we have some questions. Tucker says, can I order a parallelogram lap? Absolutely not. Oh yeah, Geek Gaming News, power out down the way. Yeah, we had a power outage. We are on generator, sir. So we're fully, I can't explain it. We'll find out later. So here we go. We have our 6-inch laps. We have our diamond slurries, and we start lapping the Toolmaker's flat. See previous videos for the Toolmaker's flat. Here is the Toolmaker's flat. And if I pull off my protective tape, I think you will agree with me, except for the schmutz I got on there, that we did a pretty darn good job of of lapping. And it actually doesn't matter what you think. The measurements say that we did about a half a band, or better than a half a band of flatness. That translates to about 200 nanometers of flatness. So, you know, we celebrated and we did the happy dance, and we're like, hey, we know how to do 3-inch laps, or 3-inch parts. So I get this message from a customer who has become a customer, and he said, hey, I see you can do that. Would you like to do it for us? And I'm not going to identify them just yet. We'll talk about them another day. And I said, sure. If you send me a first article, you know, I will give you a best effort. And he said, let's do that. I'm like, okay. So I did that, and we had an A side and a B side, and I did the A side, and it came out perfect, just like couldn't be better. I did the B side, and I actually kind of sort of shortcut it a little bit, and I was going to chase it. And I mean, we're down in the tens of nanometers here, right? And I was going to chase it, and I said, you know what? No, I think this is not so good, but I'm going to send it. And I sent it to the customer. So he had an A side and a B side. And when he came back to me, he said, hey, you know, the A side was perfect and the B side was not so good. I'm like, we are in complete agreement. That was awesome. So that made us very happy. And the measurements we're making are using optical flats and helium bulbs. So for you nerds who are wondering. So time passes, and I get an email from the customer, and he says, hey, we have some platens which are 6 inches in diameter. Can you do the 6-inch platens? And of course I said, well, gulp. Yeah, I'm going to have to make some tooling and develop a little different process, not terribly different, but I think we can do it. So he said, you're funded. So he sent me one first article, and we had to come up with a way to do that. So I decided we're going to go with 8-inch laps. And and we needed, Dale says, and take a drive up north for a bigger piece of glass. Right. So we already talked about my trip to Russell Optics up in Vermont. I bought an 8-inch optical flat, the highest grade they have. I got to meet the folks at Russell Optics. That was a great trip. I've talked about it before. Then I started making these 8-inch laps, 8-inch slabs of ductile iron from cast iron from McMaster Carr, just like the 6-inchers. Put them on the lathe. You can see them here in the slideshow. Cut a handling groove around them, which you're going to see in a minute. Put them on the grinder, and we grind them flat on the surface grinder, flat and parallel, and then we put the grooves in. And here is where we arrive at where I was several weeks ago. So we're going to do a thought experiment, and this is going to answer a bunch of questions that people had. Like, I know one of the people I'm looking at in the Discord server is like, why do you need a special shape? So if you go back to the quadrile grooves of the laps, and you go back to the fact that we take a working lap and a conditioning lap, and we lap them together, and of course we rotate and lap, and we have these different dances we do in order to be very uniform around the lap. Everything gets evenly worn. Of course, using the word worn to somebody who just made laps is a little painful. We'll get back to that in a second. In the 6-inch laps, I did notice that sometimes I would have an artifact which was a line from a lap. And I'm like, whoa, why'd that happen? Now, I didn't log it and I didn't photograph it, I don't think. So I can't exactly tell you if I noticed that line on the other lap or I noticed it on the work. I think it was on the work. And the answer is, if you push your work along what I call an avenue, okay, along one of those long straight grooves, you're going to get, over the course of that stroke, you're going to get different behavior outside the grooves than inside the grooves. And that's what I was getting. Now, did I recover from that? Yes, very quickly. And I kind of mentally like, okay, this is a thing. So every time I was working with the laps and I was doing conditioning passes, it was in my head that if they're all the avenues are lined up, something weird's going to happen. Okay? Or vice versa. So when the project came along to make these 8-inch laps and go ahead and, take everything we learned from the 6-inch lap experience and apply it to the 8-inch laps plus, that was one of the things I wanted to deal with. So anybody know what Manhattan Henge is? So I grew up in New York City, and there was this thing that happened. You could ask some astronomer when it was going to happen. Yeah, that's right. And you would get the sun setting and coming straight down one of the streets in Manhattan. And this was like a big deal. And people would line up on the sidewalks and have their phones out. And of course, now they have their phones out. Back in my day, we'd have our view cameras out and our cloths over our heads. Yeah. So this is what it was. It's like, oh, this is Manhattan Henge, except it's happening on my lapping plates. And you know what? I don't want it. So this rolled around in my head for quite a while. And I apologize. In particular, I apologize to CSK. I couldn't remember where these tiles came into my head, but I knew that there was this thing that might solve the problem. I tried, before I got there, we'll do sinusoids, right? And that had a bunch of problems. It had fusion problems. It just wasn't going to work out. Then it was like, some people like to do triangles instead of the quadriles. And then I said, no, it doesn't change anything. It's still a bunch of straight lines. So there's a second problem associated with the quadriles. So not only do you have the avenues, okay, but what if you take your avenue aligned laps? Yeah, so CSK, who by the way has some creds, says regular hexagons would be better. Absolutely. Stand by. So, actually, I think you know what's coming next. In the quadriles, if you took the lap and you moved it over a little bit and then over a little bit, you see what my fingers are doing? There's your avenues, right? And you move it over one full quadrile, you have the same problem again. If you do, so anything that is periodic is going to have some sort of periodic behavior across the lap. So there were two things I didn't want. And here's the crux of the matter. I didn't want avenues and I didn't want periodicity. I wanted it to be aperiodic. Yes, oh, Derv, you got it. We're heading there. So I wanted aperiodic and I wanted no avenues. And guess where I landed? And I can't remember how I got connected to this magical thing we call the aperiodic non-repeating tile. And there it is. Thank you. CSK says, in geometry, no avenues equals fault-free. Awesome. So, I did some research and found these patterns, and I'm like, this is exactly what I want. And the pattern you're looking at right now, which I'm going to show you in physical form, is this guy, which is called the hat, also known as the Einstein or the Einstein tile. And this is the shape you're seeing on the lap. So this thing has the property, and CSK, you could smack me if I get it wrong. This thing has the property that you can tile a plane with these, and you will generate a non-repeating aperiodic tile, except you do need to flip it over. You need a flipped over one. I came up with, I don't know, maybe 3% of the time. Is there a magic number for this guy? Every now and then you have to use one flipped over to keep life working. So if you use the properties that we just discussed, and oh, by the way, of course, I printed a dozen of these things and was playing with them on the kitchen table, and it's kind of fun. I'm not going to lie. It's kind of neat. And you can tell which side is which because one side has the texture of the build plate, the textured build plate, right? And the other side has the layer line pattern. So there you go. So CSK, who must know what he's talking about, says about 1/7 of the tiles must be flipped. Actually, 1 out of the 4th power of the golden ratio. Woo! Thank you. That's awesome. That's fantastic. So it works, and it does. Yeah, okay. Evil's got it. It works, and it solves the problems that I was trying to solve. Now, your correct next thing that you might want to say is, can you prove that it solves the problems you want to solve? The answer is not yet, because we haven't lapped with this yet. But I have no doubt that this is going to work out really well. The only doubt I have is scaling. Okay, I had to take a guess at the scaling, and I think this scaling is going to work okay. You can make the argument that maybe they should be smaller or maybe they should be bigger. I don't know. But here's the beauty of it. A lap has 2 sides. So if we have to, we could change. So here, I'm going to show you the live. Oh. By the way, these things, these 8-inch laps are 17 pounds each. So there's an 8-inch lap in the holder that I designed. So this is the reason we put the groove in around the edge. This is a derivative of the work we did on the. I'm going to switch sides here. Hang on. Oh, let me turn that guy off. This is a result of the work we did on the toolmaker's flat. Right, the toolmaker's flat has a big fat groove, and this is a small groove, but the groove handles the handles. And it also, if you follow it along, when I was making the laps, it has a hole at a particular position, and we drop a screw in it. Where's my screw? Oh, there it is. There's the screw, and it's loose. Okay, it's not tight in there. It's held loose, but you can hold it, and you're not giving any thermal input to the lap. So you can move it around, not give it thermal input, and control the rotation all at the same time. Now how much would you pay? But wait, there's more. So there's the lap after grinding. It's got some anti-rust stuff on it. And there's the beloved CSK. You should screenshot that. There's the beloved pattern. Okay, ready to go. So these guys, the next step for these laps is going to be conditioning them. So taking the 2 laps face to face, diamond slurry, and start to condition the laps. And I'm very, very excited about this. So let me read you some stuff. They don't make them light. Let's see. By the way, this is the paper. This is the paper I found, okay, which you could find. I'm going to give you a pointer to this paper later, called an Aperiodic Monotile, which I really enjoyed. Oh, Dale screenshot us. Thank you. I'm going to read you the note I sent to my customer. And here it is. I said, I have been making the 8-inch lapping plates for our project of restoring the 6-inch platens, and I have an interesting positive development. It took a while to get to this point, but I am so far happy with the results of making the new laps. Let's see. I'm jumping down to stuff that I haven't already told you. My research led me to aperiodic non-repeating tiles, which is a mathematical field of some surprising depth. In particular, the aperiodic monotile, also known as the Einstein, seemed to be a perfect pattern for the lapping plate grooves. I landed on the work of Myers, Kaplan, Goodman, and Goodman-Strauss from 2023, and I gave him a link. And then I told him a little bit more about the story, and then I sent him the picture that you guys have seen. So now I'm on to the step of conditioning the laps and starting on the workpiece. I plan on making public disclosure of this work, so feel free to share internally. Sorry, blah, blah, blah. And I also sent this to 2 fellow MIT nerds. Now, you're pretty much up to date. There's a thank you. Unix Carbide put in the Discord chat the link to the page about the hat. I'm very excited, so stay tuned. I'm not going to rush into this, but we're going to forge ahead and report back on how wonderful this outcome is. Mr. CSK, would you be willing to come in on audio and or video and tell me which? And there's a whole bunch of links coming in from printables. I will put the STL file. You could do audio? Okay, I'm going to give you an invite. You'll see a thing come up on your screen, and I will introduce you. We have a surprise for everybody. Just give me a hello.
I think I'm online.
Yes, you are here. Please welcome Mr. Craig S. Kaplan, professor of mathematics. You could yell at me if I get this wrong. Who's up at the University of Waterloo and one of the authors of this magnificent paper called the Aperiodic Monotile. Craig, welcome aboard.
Well, it's fun to be here. This is a whole world that I know almost nothing about.
Well, I'm hoping that I make the connection between the fantastic mathematical work that has been done and some real practical stuff. Did I, from where you sit, do you understand my case for wanting to go with this particular tile?
I think some of it makes a lot of sense, right? Like, you've gone into the details of like avoiding what mathematicians call fault lines, and wanting periodicity because it suppresses like repeating structure that would cause something to be lapped unevenly. I don't know that the hat in particular / t-shirt is a particularly good choice. Like aperiodicity is probably overkill for what you actually want to accomplish, and being a monotile doesn't seem to be strictly necessary, but it is a good choice. Like, it's a good thing to try. And then I would just say, like, well, there's a bunch of other stuff that we should try too to see which one laps best.
Well, one thing's for sure is if this solves the problems I was trying to solve, we have a toehold on proceeding, right? I did
Good start.
Yeah, I read up on the other. Oh, we should explain to people why I added the. I didn't do this very well. Why I added the term non-chiral to our description. Maybe you can either tell me I'm right or yell at me.
No, what you said was basically correct, which is that for this particular shape, in order to tile the plane, you absolutely need to use both left-handed and right-handed tiles. I
Yeah.
mean, that's one way of saying it.
Yeah.
A tile and its mirror image, right? The word chiral comes from hand, so it's more common in chemistry, but we can talk about chiral shapes. You need to use both left-handed and right-handed shapes. Our follow-up paper does away with that restriction and says, here's a shape that does more or less the same magic trick, but it doesn't even need to be flipped over. And that was a good response to the haters who were complaining, right? Like, you use the shape and its reflection, it's two different shapes.
Right.
I disagree with that from a mathematical perspective. Like, if you go back to Euclid would say shape and its reflection is the same shape. But if you're like making ceramic tiles, molds, you're going to need to make two different shapes from that point of view. So fair enough, right?
Yeah.
Or, a left and a right shoe are the same shape, but they're not the same, to manufacture. So it was fun to come up with a response to that with the chiral tiling.
And what do we call the next generation that is chiral?
Those shapes are called specters.
The specter. Yeah.
That's just their nickname. But we refer to it in the paper as a strictly chiral aperiodic monotile, which means all the tilings it forms are aperiodic and never allow reflections.
Excellent. So I grabbed the hat and ran with it. My excuse to you, I feel like I'm doing a thesis defense. My excuse is I had to get something done, and we ran with this, and I think it's going to do everything we want. If I was a tile manufacturer, like you said, the Spectre is even betterer. And it sounds.
But you don't have to care for this application. You're just cutting grooves into a metal plate. It could be any shapes you want, right? Like reflection doesn't cost you anything extra.
Absolutely true. And when I laid eyes on the first one, it was like, oh, this is absolutely the best. So we're looking forward to seeing what the results are. So you're up at the University of Waterloo, which is west of Toronto. And right. I assume you live in the vicinity of the university.
I live in Waterloo.
Are tiles your main thing? Is this a focus of your research and teaching?
It's one thing that I'm especially interested in. I got my start in my PhD kind of in decorative applications of tilings in computer graphics. So I was working on patterns and tilings and just interesting textures that you can make pictures of. And then kind of I got sucked into thinking about the solved problems just in the mathematical world of tiling theory. It was just incredibly good luck that I was able to contribute to the solution to one of those problems a couple of years ago.
We have a question coming in on the chat. Robin asks, do you use Maple? I don't know what that means.
So I know what the question means. Maple is a very famous piece of software that was originally developed from people at the University of Waterloo, and it's a symbolic mathematics package comparable to Mathematica, which is perhaps better known outside of academia. I don't use Maple, although obviously I'm aware of its existence. I did had to use it in some undergraduate courses, but I'm actually pretty naive when it comes to those kinds of symbolic math packages, possibly to my own detriment. I tend to write code from scratch.
I really enjoyed some of the animations that you did on the website. That was pretty cool.
Thanks.
Yeah, it was just so you guys should check out. The website is cs.waterloo.ca/tilde/CSK/hat/ We'll put that up into the description. Craig, thanks so much for this. Was the last minute, was it not? I think.
Yeah, that's what was fun to receive your email yesterday.
Yeah, and feel free.
I'm glad I was around to hop in.
Oh, it's awesome. We appreciate you so much. What are you getting for weather up there in Waterloo right now?
Glad you asked. Let me see if I can find it. It is currently 16 degrees Celsius. Thank you very much.
Lovely.
Wind west at 32 kilometers per hour.
Awesome. Any precip?
Let me have a look. It was a little drizzly earlier today. Right now it says cloudy.
You are now qualified to join us at any time on our Discord server. We might have to start.
Seems to be a hobby here. Yeah,
we have a good crew that ranges from hobby machinists up to literally master tool makers.
Amazing.
And we learn. That's why we're here, and we have fun.
I have a small amount of experience with CNC and laser cutting and 3D printing, and indirectly with like water jet, but this is all very exotic to me. Like, the first thing I did when I received your email was, okay, very cool. What's lapping?
No, the first thing you should have done is, very cool. Is this guy a criminal? So, which I appreciate.
Sure, yeah. Well, I did. I mean, obviously, that's the first thing I checked. Yeah, you're clean. Came up clean. So.
All right. By the way, I have to tell you that my dad was raised in Toronto, so.
Oh, lovely.
I have some.
Mine too, I think.
And we have,
at least for a couple.
We have Canadians here. Really.
Somebody responded. Ted Hyde said from Kitchener. Yeah.
Yeah, and then
an hour from my original home. Yeah.
And then
I
we have
live in Waterloo, not Kitchener, but whatever.
Well, we have Dale, who's over in Edmonton.
Oh, great.
And we have is Josh here? Or did Josh punch out? Josh looks like he punched out, but he's in Winnipeg, and they're regulars. We got a bunch of Canadians here, so you're always welcome. Craig, I'm going to say thank you very much, and you are welcome here anytime. Thanks for shedding some light on this crazy shape that we're enjoying.
It's a pleasure.
Take care.
Expensive.
All right. Was that cool or what? Oh, you are here, Josh. Okay. I don't know why I couldn't see you. So thank you very much. You guys have homework now. You have to go read the paper. I'll put the links in the description of the video for this PFG.Live. And once again, Craig S. Kaplan, professor of mathematics at University of Waterloo in Canada. He gave us another link if you want a more personal history. There's his personal link right there in the chat. Thank you so much, Craig. That was a lot of fun. And I think we've done it. I think we hit all the high points. Did we miss anything, guys? I'm always reminded if I did. Awesome. Okay, Machine New Zealand had to duck out because he has to work. Thank you, everybody. I'm glad you have this. Does anybody else want to see the video one more time? We need at least 3 people to raise their hands and say they want to see the video one more time. Robin wants to see the video one more time. We're done. We're going to see the video one more time. So if you need any flat stuff, go over to PFGstones.com. Pick yourself up some PFG stones because you will not regret it. If you want to join us in the Discord server, go to pfg.gg/discord. If you want to join us in celebrating lathe, you can go to pfg.gg/lathe. It's all there. It's all there for you. In the meantime, we're going to go out with the video, but I will remind you to get flat and stay flat, and we'll see you next week.
I love lathe.
I don't love all lathes, but I love this one.
I love lathe.
I love lathe.
I love lathe. Look at that finish.
I love lathe.